Welcome back to TM Academy. Okay, let's have this problem related to the average acceleration and instantaneous acceleration. Okay, a particle moves in xyz plane with an equation of motion given by the velocity as a function of time, or the v of t, is equal to 1.40 meter per second cube t square I hat plus 3 meter per second raised to 4 t cube j hat minus 2 meters per second k hat. Determine the average acceleration of the particle from t is equal to 2 seconds to t is equal to 8 seconds. And what is the instantaneous acceleration of the particle when t is equal to 3 seconds? Okay, so let's solve it one by one. Okay, for letter A, we will determine the average acceleration of the particle from t is equal to 2 seconds to t is equal to 8 seconds. Take note that since the particle moves along xyz plane, the average acceleration can be calculated by the change in velocity along x divided by delta t I hat plus the change in the velocity along y over delta t j hat plus the change in velocity along z, over delta t k hat. Okay, or the average acceleration is equal to the delta Vx is equal to the final velocity along x minus the initial velocity along x divided by the final time minus initial time I hat plus the final velocity along y minus the initial velocity along y divided by the final time minus initial time j hat plus the final velocity along z minus the initial velocity along z, then divided by the final time minus initial time k hat. So we need to solve first. As you can see, we need final and initial velocities. So to find the initial velocity, we will use the time be equal to 2. And to find the final velocity, we will let t be equal to 8 seconds. So we will use this equation of motion, v of t, to evaluate the velocity, the initial velocity when t is equal to 2, and the final velocity when t is equal to 8 seconds. Okay, so let's use this equation. Okay, so the final velocity, the initial velocity when time is 2 seconds is 1.40 meter per second cube 2 second square I hat plus 3 meter per second raised to 4 2 second cube j hat minus 2 meters per second k hat. Okay, so we have 1.40 meters per second cube. 2 second square is 4 second square plus 3 meters per second raised to 4. 2 second cube is 8 seconds cube. J hat minus 2 meters per second k hat. Okay, and this is equal to 1.40 multiplied by 4, that is 5.6 meters per second I hat, as we cancel out the unit second square, plus 3 times 8, that is 24 meter per second j hat. So we cancel out the second cube, then seconds, and minus 2 meters per second k hat. Okay, this would be the initial velocity along x, y, and z. Then to find the final velocity, that is the time be equal to 8 seconds. So v, when time is 8 seconds, that is 1.40 meters per second cube. 8 second raised to 2. Sorry, that is second square. I hat plus 3 meters per s raised to 4. 8 second cube j hat minus 2 meters per second k hat. Okay, this is 1.40 meters per second cube. 8 second square is 64 plus 3. Okay, 8 cube is 512 j hat. Then minus 2 meter per second k hat. Okay, let's cancel out first the unit. Okay, then we have now 1.40 multiplied by 64, that is 89.6 meters per second I hat, plus 3 times 512, that is 1,536 meters per second j hat minus 2 meters per second k hat. Okay, this is the final velocity along x, y, and z axis. So now we may compute the average acceleration. Okay, average acceleration is equal to 89.6 meters per second minus 5.60 meters per second divided by the final time 8 seconds minus the initial time 2 seconds I hat. So these are the values, 89.6 and 1 and 5.60. Okay, then plus 1,536 meters per second minus 24 divided by 8 seconds minus 2 seconds. Okay, and plus, again, these are the values, 1,536 and 24. And lastly, we have negative 2 meters per second and minus 2 meters per second over 8 seconds minus 2 seconds k hat. Okay, so we have 89.6 minus 5.60, then divided by 8 minus 2, that is 14 meters per second square I hat. Then 1,536 minus 24 divided by 6, that is 252 meters per second square j hat, and minus -2 minus -2, or rather that is 0, because it should be final minus, right? So this must be plus. Okay, so that is 0 k hat. Okay, so this is again the average acceleration of the particle from t is equal to 2 to t is equal to 8 seconds. Okay, then the next problem is we need to find the instantaneous acceleration of the particle when t is equal to 3 seconds. So to find the instantaneous acceleration, again, the instantaneous acceleration can be calculated by the derivative of the velocity with respect to time. Okay, which is the d over dt of the given function, velocity, this one, this is the velocity, okay. So what is the derivative of that function? The derivative of 1.40 meter per second cube t square is 2.80 meter per second cube t I hat. Then plus 3, derivative of 3 meter per second raised to 4 t cube is 9 meter per that is meter per second raised to 4 t square. And derivative of 2 meters per second k hat is 0. So this is the equation of the acceleration as a function of time. But we're looking for the acceleration or the instantaneous acceleration when time is 3 seconds. So let us just evaluate this acceleration by substituting t be equal to 3 seconds. Let us check first the time again. Yes, that is t is equal to 3 seconds. So we have 2.80 meters per second cube, 3 seconds, I hat plus 9 meter per second raised to 4 times 3 second square. This is j hat. Forgot the j hat. Okay, so 2.80 multiplied by 3, that is 8.4 meters per second square, I hat. Then plus, this is 3, the square of 3 is 9, multiplied by 9, so we have 81 meter per second square, j hat. Okay, so this is the instantaneous acceleration when t is equal to 3 seconds. That's all. Thank you for watching.